Okay, hello Math 115 students. I've created several YouTube videos going over the notes, the course content, and we're going to skip section 1.1. 1.1 is a good section. It has some good review, but we're going to get started into section 1.2. 1.2 is an intro to functions and graphs. 1.2 is we're going to talk about rectangular coordinates. And students are expected to be familiar with the rectangular coordinate system, the XY axes, the four quadrants, plotting points, things like that. And so let's get started into it. A relation is a set of ordered pairs XY. The domain is the set of all X values, and the range is the set of all Y values. So here's an example. Suppose that we have the set of points 6, 2, 4, 6, 4, 1, and 1/2, 1/3, or 1/2, -3. Negative 1/2, -3. The domain is the set of all X values, as said, and the range is the set of all Y values. So the set of all X values is the set containing 6, 4, 1/2, at -1/2, and the range is -2, 6, 1, and -3. Suppose that we wanted to know the distance from 6, -2 to 4, 6. Can I draw on that distance? So the distance formula, which is another thing we'd have to know, says the distance between 2 points x1, y1 and x2, y2 is d equals x2 minus x1 squared plus y2 minus y1 squared. We want the square root of the whole thing. So as an example, suppose that we want to find the distance between 6, -2 and 4, 6. The distance between these points is found by using the distance formula. We want the square root of 4 minus 6 squared plus 6 minus -2 squared. The square root of 4 minus 6 is -2. -2 squared is 4. 6 minus 2 is 8. 8 squared is 64. 4 plus 64 is 68. The square root is 68. We got 2 root 17 would be the exact answer. And you want to leave these in exact form unless you're stated otherwise. In the calculator, you get roughly 8.25. Okay, so that would be this distance here, which you can easily see is going to be more than 8 units. Okay, since it's 8 units from 6 to -2. And so that at least sounds reasonable. Okay, in fact, it is correct. Another question, do the points P equals -2, -8, Q, which is equal to 0, -4, and R, which is equal to -4, -7, form a right triangle? So I've got a picture of this drawn, and the points, the 3 points are labeled accordingly. And to find the distance between each of the points, we're going to use the Pythagorean theorem and see if we get a true statement or not. Okay, so let's find the distance between P and Q. So using the distance formula, we want the square root of 0 minus -2 squared plus -4 minus -8 squared. Okay, and again, I'm using the formula up here. Okay, so the change in the X values is -4. The change in the Y values is 16. I want the square root of 4 plus 16, which is the square root of 20, which would be 2 root 5 in simplified form. The distance between P and R is same deal. I want the square root of the x2 minus x1 squared plus y2 minus y1 squared. So the difference in the x's squared, I want negative 4 minus negative 2 squared. And then the difference in the x squared is going to be negative 7 minus negative 8 squared. Okay, that would be the square root of 5 when you simplify. The distance between Q and R is the same deal. So we want the square root of the difference in the x's squared plus the difference in the y's squared. So the difference in the x's squared, 0 minus negative 4, negative 4 minus 0 squared, plus negative 7 minus negative 4 squared, which is equal to 16, square root of 16 plus 7, which is the square root of 25, which is 5. Okay, so do we get a true statement from these distances? Well, the square root of 5 is 5, the square root of 20 is 20, the square root of 25 is 25. 5 plus 20 is 25. So yeah, that's true, which means that yes, this is a right triangle. Okay. As far as the midpoint formula, there's a theorem in the book stating that the midpoint of the line segment with the endpoints x1, y1, and x2, y2 is m equals the point x1 plus x2 over 2, y1 plus y2 over 2. Make sure this is written as a point and not just two x values or two xy values. I see students sometimes won't have the parentheses that's needed for any point there that you'd be describing. So suppose that I wanted to know the midpoint between the point 8, negative 4, and negative 6, 1. Okay, well, the m is equal to the sum of the x's squared divided by 2, and then the sum of the y's divided by 2. So the sum of the x's divided by 2, we got 8 minus 6 divided by 2, and then 4 minus 1 divided by 2, which is 1, and then negative 3 halves, and that's a point. So that point is the midpoint between these two. Now I can very easily check that. I can calculate the distance between this first point to the midpoint and the midpoint to the second endpoint, the two distances, and they should be exactly the same. They should be equal. Now I think it'd be a lot of work to check that distance, okay? But there is a way to check your answer. Another example that we have is a circle written in standard form. The standard form of an equation of a circle with a radius r and center hk is x minus h squared plus y minus k squared equals the radius squared. Suppose that we have a circle that we want to graph, and the circle has a radius of 3 and a center point at negative 1, 2. Well, in standard form, which is also called center radius form, I think in a couple of books, although most books use a standard form as the appropriate form of this equation. But in the standard form, we want x minus h is negative 1, x minus negative 1 be the same as x plus 1 squared plus y minus k, k is 2, y minus 2 squared equals the radius squared, 3 squared is 9. And so that would be um, the form of the circle that I want. And the circle then is graphed on the XY plane provided. So as I set up my axes and I plot the center point, which is at -1, 2, and then use a radius for 3. Now I've got 4 points, 2 left, right, 2 up, down, that are 3 units away from the center, the radius of 3. And that's what I want in this problem, since the radius is 3. And you can label these points if you want, or not, it doesn't matter. But make sure that the points are there. What I'm looking for in a problem like this is that you have the center, which is given, and the radius, creating 4 points around the center, as you see here. Okay.